Hello, everybody, and kia ora. So in today's webinar, we will talk about our project that provided expert technical input into the revision of 7 Australian standards for bitumen and related materials. We have more than 300 people registered for today's session. Welcome to you all, and thanks for joining us. My name is Ekaterina. I'm a communications officer at Austroads, and I will be moderating today's session together with Robert Buzatil from the Department of Transport Victoria. Robert will moderate the Q&A at the end of the session. First of all, I would like to acknowledge the Australian Aboriginal and Torres Strait Islander people as the custodians of the land from which we are broadcasting today. I pay my respect to all this past, present and emerging. I also acknowledge the Treaty of Waitangi and Maori as the regional people of New Zealand. A little bit about Austroads. We are the collective of Australasian transport and traffic agencies, and our focus is to support our member organizations to deliver an improved road transport network. The project that we are focusing on today was delivered under the Transport Infrastructure Program, which is managed by Ross Guppy. A bit of housekeeping. So our presenter will speak for about 40 minutes, and then we will have a Q&A session for 15 minutes. The slides for today can be downloaded from the handout section of your sidebar, which you will find on the right-hand side of your screen. To send us your questions for the Q&A, please use the questions icon on your sidebar. If your question relates to any particular slide, please include the number of that slide in your message to help us answer your question as best as we can. Also, let us know if you have any technical problems, but a quick tip: if you lose sound or your picture freezes, the issue is most likely with your internet connection. So closing your browser and rejoining the session by your email registration link usually helps. This session is being recorded, and we will let you know when the recording is published on our website. If you listen to podcasts, you can also find Austroads in your podcast tab. So it gives me great pleasure to introduce our presenter for today, Robert Urquhart. Robert is a national discipline leader at the Australian Road Research Board. Over the past 11 years, he has contributed to numerous Austroads research projects on bituminous binders. He has also been extensively involved in the revision of several Austroads test methods and Australian standards relating to bituminous products. So welcome, and over to you, Robert.
Okay, where's the...
It's on its way. Here you go.
It's on its way.
Yep.
Okay, now I can see me. Okay, can everyone see that?
Yep, all good.
Okay, all good. Okay, thanks very much for that introduction, Ekaterina. As Ekaterina said, I'm giving a presentation on a 2-year project which involved me updating several standards, Australian standards for bitumen and road making materials. In terms of the presentation, it's got a few sections. I'll initially talk about the team that updated the standards, give a bit of a project background and aim, give you a bit of an insight into the Standards Australian revision process. Now, during this project, 3 standards were revised and published, so I'll talk about them, basically what the principles of the tests are and what changes we've made. And 4 are currently undergoing revision, 3 are close to being published, and 1 has been reviewed, so I'll talk about those as well. Finally, I'll give a summary of where the status of the Australian standards are, and then there'll be a Q&A session at the end of the webinar. So in terms of an introduction to the team, the project team mainly involved the Austroads project manager, John Ainoff. I was the technical lead who supported the standards updates, and the main project contributors were members of the Australian Standards CHO 25 Committee, Bitumen and Related Projects for Road Making. The standards that were published and reviewed were also reviewed by the Austroads Bituminous Surfacing's Technical Group and the Austroads Pavements Task Force. In terms of the CHO25 Committee, Bitumen and Related Products for Road Making, that group consists of an Australian Standards Australia project manager, Andrew Mackay, who keeps us on track and does all the paperwork for the standards, including for Standards Australia. There is a CH025 chairman, Robert Buzzattle, who's on this webinar. And on the right-hand side of the slide are the members of the CH25 committee, which represents people from industry, road authorities, and also other interested parties such as CPEE and OSTAB. So in terms of the project background and aim, the Standards Australia CH025 committee is responsible for the revision of 4 national specifications. They're the national specifications for bitumen, cutback bitumen, bituminous emulsions, and cutter or flux oil. And they're also responsible for updating the 30 test methods associated with these products. In an ideal world, Australian standards would be ideally reconfirmed. That's the committee has a look at them and says, oh, we don't need to change anything, or revised every 10 years. That's an ideal world. Many of the Australian standards covered by CH025 have not been updated for more than 20 years. And I've given an example of one distillation of cutback bitumen on the right-hand side, which is in this webinar, which hasn't been updated since 1994. You could say, okay, if a standard, an Australian standard is not current, who cares? There are a number of problems with if an Australian standard is not current. Some of these include that the specified materials or equipment, you can't get them anymore, or the standard might specify an older type of equipment where a newer type would be far better to do the tests. What we've found, we've reviewed quite a few of the standards, is some of the test methods have got things in that are not best practice in terms of health and safety. One example of this is a lot of the test methods say you have to use a mercury thermometer, and there's dangers with that if you break the thermometer and mercury goes everywhere. So what we've tried to do in the standards is to keep the mercury thermometers, because some labs still use them, but also use things like thermocouples that are safer to measure temperature. In the worst case, if a standard's completely out of date, it might be necessary for labs to write in-house test methods to cover the deficiencies that are actually in the standards in order for them to meet National Association of Testing Authorities NADA requirements. Now, I'll just mainly talk about Australian standards related to emulsions and cutback bitumens in this presentation, but there are some Australian standards that can be used to measure the properties of polymer modified binders. That's the bitumen modified with polymers, and I've given 2 examples there. But most PMB related test methods in terms of characterizing PMBs are Austrode's test methods, such as ATM 102 and AGPT 108. The specification for polymer modified binders is a national specification as Austrode's technical specification ATS 3110, and I've shown you the front cover of that specification on this page. So in terms of the project aim for this particular project, it was to provide independent and balanced expert technical advice during the development and review of Australian standards by the Standards Australia Committee between August 2020 and September 2022. The other aim of this project was to provide updates on project progress to the Austrode's Bituminous Surfacings Technical Group 3 times a year during the course of this project. And this project was actually an extension to a previous Austrode's project, which covered the 2 years before that. And there looks like there'll be a further project for the next 2 years to keep on updating the standards. So in terms of the actual work that was done in the project, as I said before, 3 Australian standards have been revised and published. They include emulsion sieve residue, emulsion water content by Dean and Stark, and emulsion residue, and I'll talk about them later on in the webinar. We also revised or reviewed 4 standards. The revised standards included the standard for rotational viscosity, emulsional sedimentation, and distillation of cutback bitumen. And we also reviewed 1 standard, flashpoint of cutback bitumen, and decided it could be replaced by another test method. And I'll talk about that at the very end of the webinar. Okay, so that's just basically the scope of the project. This Australian standards revision process is actually quite complicated, and it takes quite a while to really revise a standard. So I'll just briefly go through that. In terms of the Standards Australian revision process, the first thing that has to happen is a project proposal needs to be submitted to Standards Australia, and that needs to be supported by the people that use the standard. Once that project proposal has been accepted by Standards Australia, the CH025 committee reviews the old document and prepares a revised draft. Once that draft is prepared, it then goes to a Standards Australia technical editor who checks it to see if it meets all the rules and whether you should use shalls or musts or shoulds, and checks all that out. Once that's done, the draft is released for public comment, which takes about 2 months, and any member of the public can make a comment on a standard. Once those public comments have come in, the CH025 committee then addresses the public comments and changes the standard as appropriate, and the revised draft is again edited by the Standards Australia technical editor. Once that's done, the final draft is prepared, and there is like a survey, and every member of the Standards Committee has to agree to the revised version of the standard. Once that's done, the revised standard is published. So I'll now go through the 3 standards that have been published in the current project. Then I'll talk about the ones that have been revised and the ones where we just reviewed it. So the first standard that was published and revised was emulsion sieve residue. And basically what this test is, it measures the amount of large broken particles in a bitumen emulsion that would particularly block pumps or sprayer jets or something like that. So this test is basically looking for relatively large lumps in emulsion. The test involves taking an emulsion sample and passing it through a sieve of 1 or 2 different sizes. The emulsion goes through the sieve, then you wash it with a surfactant solution to get the black bitumen out, and then you wash it with water to get rid of the soap. Then it's dried in an oven. Basically what the test does is work out the percentage mass of material that doesn't pass through the sieve. If there's a lot, it'll block a pump. And the reason why you do this test is the bituminous emulsion specification, AS 1160, has maximum sieve residue limits for different emulsion grades, such as ARS, ASS, and CRS. In terms of changes that were made to this standard, when we had a look at the standard, it is possible to get an emulsion with a very high sieve residue, say 10% or something, and we realised that you can't actually do this test because the sieve gets blocked. So we've now made it that the standard is now applicable to sieve residue results less than 1%. In the original version of the standard, the diameters for those 2 sieves were different. We found out that most labs use the same diameter sieve, so we've changed it so that the 2 sieves have a diameter of 100 millimeters, which reflects what was used in the lab. The amount of emulsion required by the 710 micron sieve has been reduced from 2 litres to 200 grams, just because of the fact to pour 2 litres of emulsion through a little sieve like that is very difficult. Other things we've done is the plastic wash bottle has been included to dispense the surfactant solution, and the requirement to use distilled or deionized water has been removed. Other changes to the standard to account for high binder content emulsions are that high binder contents can now be diluted with up to 50% of the surfactant solution before you put it through the sieve to facilitate rapid flow of the emulsion through the sieve. If you've got a high binder content emulsion, it's very viscous and it's very hard to tip that through the sieve. The final thing that's been done for this test method is that the precision test limits, the repeatability and reproducibility have been updated. The second Australian standard that's been revised and published is emulsion water content Dean and Stark. And this test basically measures the amount of water in a bitumen emulsion or even a refined tar. The bitumen emulsion specification has maximum water content limits for different emulsion grades. If the water content's too high, there isn't enough bitumen in the sample, so it gives you an indication of the bitumen content. And you can also use this test with the water content and the bitumen content together to work out the kerosene level in an emulsion cutter or kerosene. And the emulsion specification has maximum water content limits for different emulsion grades. In terms of the test, I'll put a picture of the test over on the right-hand side of the slide. And basically an emulsion sample is placed in a round bottom flask and 100 ml of solvent, typically xylene, is added. The flask is then heated, and this is sort of like a distillation apparatus. The water in the sample evaporates and then gets recondensed in the water cooler condenser on the right, on the top of that picture. That water, once recondensed, goes into something called a Dean and Stark receiver, which basically has little lines on it that tells you the volume of water. And the volume of water in the receiver is used to determine the water content of the sample. Now I'll just go through some of the changes to the emulsion water content test. One of the problems with this one, and also in another one of the standards that I'll talk about, is that the equipment was specified and you couldn't actually get it. So the 1992 version of AS2341.9 said that the Dean and Stark apparatus, that's the equipment you needed to use, needed to meet the requirements of AS-R25 Dean and Stark apparatus. Now, the fact that that Australian standard has a letter in it means it's really old, like from the 1930s and 1940s. So we went to Standards Australia and said, do you have a copy of this standard in the archives? And the answer was no. So we couldn't reference that. We had a look to see if there was other standards for Dean and Starks. There were, but we also went to some Dean and Stark manufacturers and said, do you make your equipment to a standard? And all of them said, no, we don't. We just make the equipment. So based on that, the requirements of the Dean and Stark have been changed to reflect the things that will affect the test result. One of the main things that will affect the test result is the volumes of the graduations in the receiver. So that's now specified in the standards. And we've also given an indication of the approximate sizes of the round bottom flask and condenser as sort of a sense check to not try and use something too big or too small. The other thing that's happened with this test method is the test precision limits, the repeatability and reproducibility have been updated to reflect the results of 4 round robins that were organised by ConLabs between 2016 and 2020. And on the right-hand side is a picture of the published standard, the front cover. The final standard that's been published is AS2341.41 emulsion residue. And this is predominantly used to separate out the bituminous component, the bitumen in the emulsion, so it can be further tested. AS 1160 says, which is the emulsion specification, says, do this test, get the bitumen out of the emulsion, and then subject it to viscosity at 60 and toluene insolubles tests. AS 1160 also recommends that evaporation residue tests be performed on CAM grade emulsions, which contain a high level of solvent, typically diesel. These emulsions are normally used in coal mix applications using AS 2341.30. This is different from the other emulsion grades where evaporation tests are done using AS NZS 2341.23. The test AS NZS 2341.43 basically involves placing an emulsion sample in a metal container, normally a metal tin, and heating it to boil off all the water and the kerosene. This emulsion residue test is a bit more complex than that. The emulsion residue tests, the 0.30 tests, are done under an inert atmosphere to stop the bituminous emulsion component oxidizing. And these tests also involve repeated sample heating so you can get as much solvent out as possible. And that's probably one of the reasons that the emulsion specification recommends these tests on CAM grade emulsions, which contain a high level of solvent. Over on the right-hand side of this slide, I've just got a picture of how the test is sort of set up. A metal container is placed on a hot plate, and a mixture of emulsion and reagents, which is a 2-to-1 by volume blend of methylated spirits and water, is placed in the metal container. You have an inert gas pipe flowing inert gas, typically carbon dioxide, into the tin, and a stirring rod to make sure the emulsion doesn't form a skin. The emulsion is heated on a hot plate under that inert atmosphere until its temperature is about 130. The sample is then cooled to about 50, and then the sample's measured, and the process is repeated until the loss in mass between successive evaporations is less than 0.2 gram. In terms of changes to the emulsion residue test, the system used to deliver the inert gas was a bit undefined in the original version of the method, and the grade of methylated spirits was also undefined. So what we've done is tighten those things up. The grade of methylated spirits now says commercial grade methylated spirits, because we wanted to say methylated spirits from Bunnings, but we weren't allowed to. The technical editor didn't let us. One of the safety things we've improved in this method is that the 1996 version of this test asked for the emulsion reagent mixture to be stirred with a thermometer. That's a bit dangerous if you're stirring it with a thermometer and it's got mercury in it, and the mercury comes out of the thermometer when it breaks and it's heated, and that's not good. So what we've done in this method is replaced the stirrer by a separate stirring rod and an infrared thermometer to measure the temperature for safety reasons. And because the evaporation residue result is only required in the emulsion specification for CAM emulsions, the calculation of evaporation residue test results is now optional. So they're the standards that have been revised and published. I'll just go through the 3 standards that are under revision and the final standard which the committee reviewed. The first standard that was reviewed by the committee was rotational viscosity. And this test is actually used for quite a number of bituminous materials, including bitumen, PMBs, and emulsions. And there are specified temperatures in the relative representatives specifications that each of these binders need to be tested for rotational viscosity. The basic principle of the test is a sample is placed in a temperature controlled chamber, which I've tried to draw on the right hand side of the slide. And the black is the sample, and a rotating spindle is placed in the sample, and the force required to rotate that spindle at a certain speed is related to the viscosity of the sample. Taking that force, the viscosity of the sample is calculated using the force, the geometry of the chamber and spindle, and the rotational speed used during the test, i.e. the RPM that the spindle's rotating around. Now, this standard was originally revised so that viscosity at 25 tests on emulsions could be tested using a rotational viscometer instead of an angular viscometer. And we're trying to actually modernize these here, because an angular viscometer is a brass container with a hole in the bottom, and you put a stick in to block the container, and then you pull the stick out and you measure the time it takes to fill a volumetric flask. This test is a bit more advanced than that, and you don't need a stick in order to do the tests. Even though this was the initial idea of revising this standard, several additional issues were identified with the 2015 version of the test. The 2015 version of the test only allowed an L series Brookfield viscometer, are to be used to test binders. What we found was that several different laboratories had L series and several different laboratories had R series, which are a little bit less accurate than the L series. Since the last revision of this test in 2005, a number of NADA audit issues have been picked up by labs, which have been associated with the validation of the temperature control chamber. You need to do a validation process in this test to make sure that the temperature is right. And the calibration oil viscosity validation. You need to check that the instrument is giving the proper viscosity by putting a calibration oil of known viscosity. And several labs have been picked up by NADA because of the wording in the test. The other thing that was a bit lacking in this test method is there was a lack of details relating to the testing of cutback bitumens and hot poured joint sealants. So we've put those extra information in this test method. So in terms of change to this test, if you actually look on the right-hand side, this is a picture of a Brookfield viscometer that you typically do the test with. A procedure to test emulsion samples at 25 has been included in the standard. Other changes that we've made is that the Brookfield viscometer model that can be used to test different bitumen as products has been specified. Bitumen and bituminous emulsions and cutback bitumen samples need to be tested with an L series Brookfield viscometer because this one's more sensitive than the R series. And at the current time, PMBs and hot poured joint sealants can be tested using either an L or an R series Brookfield viscometer. Other changes we've made is that the temperature control chamber validation procedure has been rewritten to be a step-by-step process, as some of the NADA auditors got a bit confused about what was actually the intention of that section in the old method. The calibration oil viscosity validation has been modified to be a bit more clearer, and additional details have been included about the testing of cutback bitumens and hot point joint sealants. In terms of the status of this standard, a revised version of AS 2341.4 was released by Standards Australia for public comment between June and August this year. And currently we have 5 public comments, and they will be addressed by the CH025 committee prior to publication of the standards. And we're hoping to have a meeting in the next month or so. The second test that's been revised in this project and has not yet been published is emulsion sedimentation. These tests investigate whether an emulsion will separate or break when it is stored for an extended period. Basically what the test involves is taking a 500 ml measuring cylinder, and I've got a picture on the side where it's got some taps. You don't have to have taps, I'll go into that then later on. So you put 500 mils of emulsion in the measuring cylinder. You then let it stand for 3 days at room temperature. In the current test, after it's stood there for 3 days, the water content is determined on the top and the bottom 50 mils of the 500 mil sample so that a sedimentation result can be calculated. Basically, the premise is that if the bitumen sinks to the bottom, there'll be more water on that top 50 mils than on the bottom 50 mils. The bitumen emulsion specification has maximum specification limits for different grades, and that's one of the reasons why we were doing this test, changing this test. The original scope of revising this test method was that sedimentation tests could be calculated using evaporation residue test results using AS/NZS 2341.23 rather than Dean and Stark water content results, which I talked about a bit earlier in the webinar. The reason why there was a request to use evaporation residue results rather than Dean and Stark water content results is the evaporation test. The standard evaporation test just basically involves putting an emulsion in a tin and heating it so you get the bitumen content. It's a quite quick test, whereas the Dean and Stark water content test is a quite long test to do. Whether you measure the change in bitumen content, when the emulsion sediments or water content, you're pretty much going to get the same answer both ways. So that change has been made to the standard. We've also made some other changes to the emulsion sedimentation tests. In terms of the glass measuring cylinders that were included, it was quite vague what sort of glass measuring cylinders you could use. And it also specified the way it was that the glass measuring cylinders had to have glass tops, taps and stops. Now, it doesn't actually matter if those stoppers and taps are made out of plastic. So we've included glass measuring cylinders with plastic stoppers or taps are now allowed in the method. As I mentioned before, the standard also allows you to not use a measuring cylinder like that's illustrated on the right-hand side up the top. It also allows you to use measuring cylinders without taps. Now, if you use that, you have to get the emulsion out of that measuring cylinder. And the way you do that is with the glass pipette, which is in the middle slide, middle photo in the 3 photos on the bottom. Now, originally when I was very young in chemistry, one used to get the emulsion into one of those pipettes by actually sucking it up with your mouth. And I'll put a picture from the 1940s of how that was done. Now, that's not a good thing to do, particularly if you suck the emulsion into your mouth. In about the 1980s, something called a rubber pipette filler was invented, and we've now included that in the test method to use the pipettes rather than sucking it up in your mouth for safety reasons. In terms of other changes to the standard, the apparatus section has been included to include all the equipment needed for the test. The original version just talked about the measuring cylinder and didn't talk about anything else. And the procedure relating to the use of measuring cylinders, both with and without taps, has been clarified. In terms of updates of where this standard is currently at, a revised version was released to Standards Australia for public comment in July, and the public comment ended earlier this week, and no public comments were received. So hopefully this one can get approved by the committee and get published in the near future. The last standard that's been updated in this project is AS 2341.15 cutback distillation. Now, this test is used to determine the bitumen content of a cutback bitumen. The cutback bitumen specification, which I'll put an excerpt in the picture below, contains 8 cutback bitumen grades, which range from AMC 00 to AMC 7. And the essential difference between these different cutback grades is the amount of bitumen that's in there and the amount of cutter. So AMC 00 has the most amount of cutter and AMC 7 has the least amount of cutter. In terms of this test, the cutback bitumen specification has minimum residue from distillation requirements for each cutback bitumen grade. And if you look closely, you can see the limits in the picture and on the bottom of the slide. In terms of this test, it involved placing a cutback bitumen sample of 200 mils in a distillation flask and heating the sample to 360 degrees. If you have a look at the pictures I've got in there, that's a picture of the distillation flask with a thermometer. That is then put in a special metal shield. The distillation flask, you can see the thermometer sticking out the front, top, and then it's connected to a distillation apparatus and a distillate receiver. Basically, how the test works is you heat the sample with a gas burner. The cutter in the cutback bitumen evaporates, goes through the water-cooled condenser, and then returns back into liquid, and then is collected in the distillate receiver. And that's a measuring cylinder, so you can measure how much distillate comes out. The amount of distillate produced in the test is used to calculate the residue from distillation to 360, which is the bitumen content. This was another test method where you couldn't actually get the equipment to do the test. And I've given an example of what's in the test method in terms of the size of the distillation equipment. It was very specified, and the shield was also very specified as well. This is a distillation, so it doesn't actually matter if the size of the components is different. What actually matters is the temperature. What we did during revision of this standard, there are 2 labs that are NATA accredited for the test, and they both indicated they couldn't meet the equipment size requirements of the old method, even when the equipment was made by a specialist glassblower in a university department. What we've done as a result of this is the equipment size requirements have been relaxed in the revised version of AS 2341.5. As I said, it's a distillation. It doesn't matter if the condenser is 200 mils or 250 mils, it's still going to work. So we've basically relaxed the equipment requirements. And we've done that in a way, there's a number of overseas cutback bitumen distillation methods, ASTM D402 and EN 13358, which do have equipment requirements, and it does look like you can purchase equipment meeting those requirements from overseas. So we've made the equipment size requirements in AS 2341.15 such that you could use an overseas set of equipment for cutback distillation. Another change that we've made to this standard was that the 1995-4 version required that you basically do the distillation, and at the current time you do the distillation and you measure the amount of distillate at 360. The older version of the standard wanted you to do that at a variety of different temperatures. And the reason for that was that in the 1997 version of the cutback distillation bitumen specification, those volumes at different temperatures were specified. As that requirement hasn't been in the specification since 1997, we've removed the requirement in this test to determine distillation volumes at temperatures lower than 360. We've also made several changes to this standard for safety reasons. So the new version of the standard allows samples to be heated using either a gas burner or an electric heating mantle. We've done that because a gas burner is a flame and you've got a flammable material. A thermometric device such as a thermocouple can be used instead of a thermometer. And one of the nuances of this test was it basically said, do the test, heat the sample up to 360 degrees, and then take it apart and then pour out the bitumen. Now, there's a definite risk of what's called auto ignition, which basically means the whole thing catches on fire if you do that. So we've reviewed the European version of this standard, and they allow cutback residues to cool to 180 degrees before you take the whole equipment apart and then pick it up and pour it into a tin. So you can now do that cooling step rather than have the risk of it catching fire. In terms of the status of this test method, a revised version of AS 2341.15, there's a mistake there, has been released by Standards Australia for public comment. Now, if anybody listening to this webinar wants to make a comment, you can visit the Australian Standards website. You go into the section that says public comment. You have to register with Standards Australia with a username and password, but once you've done that, you can go in and see the draft version of the standard, and you can put some comments in, which will be looked at by the committee. And the consultation for this Australian standard closes on the 20th of October 2022. The final standard that I'll talk about is one that's been reviewed by the Standards Australia Committee, is cutback bitumen flashpoint. And these tests are done to basically look at the flammability of a bituminous binder. We reviewed this standard, and the take-home message is we agreed that this standard, which is very particular to Australia, could be replaced by an international flashpoint method, ASTM D93, in a future update to the cutback bitumen specification. One of the reasons that we decided that ASTM D93 seems appropriate is in the dangerous goods code for flammable materials. ASTM D93 is included in one of the tests that you can conduct flashpoint tests on flammable materials, but AS2341.16 isn't included in the tests allowed in the dangerous goods code. So finally, I'll just give a summary of where all the standards are at. As discussed in the webinar, as a result of this project, 3 Australian standards, emulsion sieve residue, emulsion water content, and emulsion residue, have been revised and published by Standards Australia. 2 have currently undergone the Standards Australia public comment process, that's rotational viscosity and emulsion sedimentation. In terms of cutback bitumen distillation, a draft has been submitted for public comment, which closes on the 20th of October 2022. And for cutback bitumen flashpoint, the committee has decided it will be replaced by ASTM D93. So that's the end of my presentation. It's now question time. Thank you.
All right, everyone can see me. So good afternoon, everyone. My name's Robert Buzatil. I'm just moderating the questions today, question and answer session. So thank you for that presentation, Dr. Urquhart, very informative. Not too many questions today, so you've done a good job in informing everyone and educating everyone. First question we had was about public comments. Do many members of the public comment on the draft specifications during the review period? Depends what you call a member of the public.
Yes. We've had between none and 15. A lot of the time the public comments come from the Standards Committee. But yeah, we have had comments from jurisdictions. It's advertised that it goes to public comments with the Austros meeting groups. Every public comment that comes out, a notice is made to the Austros Pavement Task Force that people can go in and have a look and make some comments.
So when people make public comments, there's they might raise an issue, and then either the committee or someone on the committee will address that, and that will then go back to the person who's made the comment. So it's not just they make a comment, it's not just a one way.
Yeah.
There is some feedback going back to that person as well. So but yeah, generally we don't get sort of people from the public, wider public. It's industry people or road authority people commenting. Yeah. Another question was about the Brookfields, and you mentioned about the L and the R series, and there's a question about what's the difference between those.
The L series is more sensitive to lower viscosities. The difference is basically what's called the spring constant. So the Brookfield is more sensitive in, say, the low range, and the R series is more sensitive in a higher range. It will go up to higher viscosities. So the Brookfield goes from there to there, and the L series goes from there to there, and the R series has a wider range. So the viscosity measurement you get isn't as accurate.
For the L series?
For the R series.
Sorry, for the R series, okay.
Yeah.
All right, okay. But they operate under the same principle, essentially.
Yeah.
Yeah, okay.
One, the force transducer is more sensitive than the other one. So the L series got a very sensitive force transducer, and the R series has got a less sensitive one.
Okay. All right. All right, so hopefully that answers that question. about it's a question about 2341.15. We've got a heating the sample to 360 degrees. Any particular reason why it's 360, why it's not higher or lower?
That's what it was before. That's my answer. When I looked at the American one and the European one, it's also 360. I think 360 was chosen because it's close to the upper boiling point of most cutters that are put in cutback bitumens.
Okay. Yeah, we're done for questions. So unless anyone's got a burning question, lots of people saying thank you for a great presentation. There you go. I think that's probably it for the questions, really. Done a good job.
Yeah, well done.
All bamboozled everyone.
We could probably tell people once these standards are updated, you'll probably notice a lot of them are more the test methods as well. You know, telling you how to do certain tests. That the idea is to do those, and then we can move on to updating some of the other standards like AS 1160, which is for bitumen emulsion, and AS 2157 for cutbacks. So the idea is do the test methods first that are referred to in those standards, and then move on to the particular standards which tell you the properties of the materials that you're looking at. So that's a general principle we're trying to follow. Even AS 2008, which is for bitumen, that'll probably be due for a review soon as well. That might be controversial, but yeah. All done.
Right. Thanks. Thank you both. Well, if there are no more questions, I will just briefly talk about our future sessions, and we can let everybody go then. So as you can see on the screen, we have a variety of webinars coming up. You might be particularly interested in the sessions that relate to road asset management and sustainable pavements. So join us on the 18th of October to hear about the use of business intelligence tools in road asset management. And on the 25th of October, we will have a session to take you through the Austroad's road asset data standard. And in November, there will be a webinar on the use of recycled plastics in road pavement. So if you're interested in any of these webinars, please go to our website and register. And as usual, when we close out today's session, a questionnaire will pop up on your screen. So please take a couple of minutes to provide your feedback. It really helps us to know what you liked or didn't like about the session, and what suggestions you have for our future webinars. Once again, today's session is being recorded, and we will send you the link to the recording when it's published on our website. Thanks again, everyone. Stay well and safe, and enjoy the rest of your day. We will see you next time.